So let's start with your mole to mole ratios. So when we look at balanced equations, they're kind of like the recipes of this chemistry cookbook. These coefficients represent the amounts that we're going to put in. However, we're not going to put them in gram amounts. We're going to put them in the mole amount. Let's pick a different color. Let's go green. So, for example, when we're looking at how we put together water, the synthesis of water, we have 2 moles of H2, 1 mole of oxygen, because the 1 is implied, and 2 moles of water are created. So if we were to write this or say this, we would want to say we were going to mix 2 moles of H2 and 1 mole of oxygen to get 2 moles of water. And that's what we get from looking at that balanced equation. So we look at this and we're able to basically set up this ratio, okay? If we're to look at and compare the H2 with the H2O, we would notice that it's a 2-to-2 ratio, right? So we're going to take the mole amount there and the mole amount there, and we always want to simplify it, so we can reduce that down to 1-to-1. So it's very similar to setting up a fraction, and from there you can basically do the math. I'm going to show you dimensional analysis, not only in this video, but the next video, which is the combined stoichiometry notes. So keep in mind, just like a recipe, this chemical equation, you can double it, you can triple it, you can half it, whatever you need to make as much product as you need. So you just have to keep in mind that the ratio of the substances in the equation, and again, you have to make sure this equation is balanced, you're able to determine how one substance you'll need a specific amount for, or if you want to make up a certain amount, that you can use that ratio to do that. So let's do a couple of examples here. So very similar to what we just discussed, okay, we have the balanced equation, the synthesis of water. So we're able to look at this and we're able to say, okay, well, how much water will be produced? We're going to take a look. 2 moles, okay? However, how much water will be produced if 5 moles of H2 are completely reacted? So we have to be mindful now, okay, well, wait a minute. We have to set up some kind of ratio. So let's do that, okay? So if we know that we normally have 2 moles of H2 makes 2 moles of H2O, if we're able to say we have 5 moles of H2, we're trying to solve how much H2O. Now you can do the math, which is basically just doing your cross multiplication, or you can see that it's a 1-to-1 ratio. So ultimately, I'll show you the first example. Okay, we would do 2x equals 10, solve for x, and x is equal to 5. Or you can just look at it by eye and say, well, that there's a 2 on the left, that there's a 2 on the right, 5 on the left, there'll be a 5 on the right. Okay, so we're able to kind of take that ratio and use the balanced equation in order to get what we want. Okay, so let's take another example. Using, again, the same equation, the synthesis of water. How much oxygen will be consumed, so we're talking about this guy, if 5 moles of H2 are completely reacted? So let's set up our ratio, okay? So we have 2 H2s, okay? But now we're not looking at water. We're looking at oxygen. So we know that there's 1 mole of oxygen there. This is asking us if we have 5 moles of H2. So now we have to figure out how much oxygen will be consumed. So in doing so, we're going to cross multiply. You get 2x equals 5. And x is going to equal 2.5 moles. And again, we're solving for oxygen. So it's a good idea, just so that you can kind of keep with the math. The number, you want to have a unit for it. So let me just go back to this example. In this example, X equals 5 moles of what we were solving for, of water. Okay, let's look at another example. Okay, this here is a reaction between ammonia and oxygen, creating nitric oxide and a whole bunch of water. So what we're going to do is we're going to look at what we have. 12 moles of oxygen, so we're looking at oxygen, are consumed. How many moles of NO are produced? Okay. So if I read along and just kind of keep it honest with, okay, well, I'm looking at oxygen, I'm looking at nitrous oxide, I can forget about everything else. So to do this, we set up our ratio. So we have 5 moles of oxygen equals 4 moles of NO. 12 moles of oxygen, how many moles of NO? Cross multiply. Do the math. X is going to equal, X is going to equal, sorry about that, 2.4 moles of NO. And let's look at the last one. Same equation. It's a good idea, again, if you highlight as you go. So 3 moles of oxygen, so I'm looking at that, are completely consumed. How many moles of NH3 are consumed? So let's set it up. 5 moles of oxygen, 4 moles of NH3. In this example, 3 moles of oxygen. How many moles of NH3? So we have 5x equals 3 times 4, which is 12. Okay. Move this up because my hand is hitting the wrong areas here. So x is going to equal, divide this by 5. In doing so, x equals 2.4. All right, so if you have any questions, be sure to email me.